I think the first part is so easy for you, right? Yeah. So I think you already have the confidence to think this trading is very simple. So we will do the next part. Okay. Someone say don't know what's the e-learning video pass, right? I have 1 minute to introduce for you. It's very easy. First, you have to visit the region website office here and find the path on the support. And on the middle one, we will have the e-learning. And click here. Of course, you have to register and log in. First step. Then you will find the roadmap. And here you will see the RCNA course. You can see what's the basic, layer 2 technology, layer 3 technology, and some advanced technology. Then you can do, if you see all the video, you can do the course evaluation. You can give me some suggestions. For example, maybe the course is too difficult, or maybe too simple, or maybe which chapter you should do better, something like this. And the last one is a re-exam, the RCNA exam here. But pay attention, you only have 3 chances of the exam. If you are not passed first time, you have to come back to see the video again, and then to join the second part. We never provide the 4th chance to you, so please prepare well and start the exam. And about the exam, totally 100 points, and over 60 points you will pass. And when you do the exam, please don't cut the screen. If over 5 times, you will submit the exam automatically. Okay, so this is exam information. And we have lots of video here. Nearly 50 videos, DHCP, VIP, something like this. And we also provide the PowerPoint for you. This is the material, and we have the video, and we also have DHCP lab. So if you have the simulator, you can do the practice, follow the lab together. Or maybe if you don't have the device or maybe simulator, you can directly to see the video. I also explain detail one by one, like today training for you. Only focus on the principle. So this is a basic e-learning. And now we will continue about the next part. Communicate between different hosts, right? For example, we already now add the VLAN and STP, and also add the, it's enough, right? Add the IP address. So the terminal in the same department, they can communicate with each other. Yes, totally, yes. You cannot join the exam again, so prepare well. Because someone may be saying this is too difficult, but if you see all the video one by one, I think you must pass the exam. So you have to prepare everything and then to join the exam. Okay, I hope you also can pass the certificate, pass the exam and get certification, because already over 100 people gets the exam, gets the certification, and someone already joined the activity before the training to show their certification on Facebook. So I am also waiting everyone's certification on our Facebook. So now let's see the next part. If we want to do the communication between different segments, right? For example, if the IT want to communicate with sales too, we have to add the routing information. So now let's have a brief introduction about the IP routing. And what's the function of the IP routing? This is used to guide the path information of the IP packets. For example, now we want to send the message from the first segment to the second segment, something like this. And how to get the IP routing, how to make the IP routing table, more information, more entry, we will have 3 types. The first one is direct routing. If you give the correct IP address and the physical interface data is up, you will directly get the direct routing. The second one, if we don't have the direct routing, maybe we already have the other router to connect with each other, we need to add the static routing. Static routing means configuration by the administrator. So you have to add every segment in the network. And the advantage is it's very simple. The disadvantage is if you do the wrong configuration, if you forgot to add the routing information, then they cannot wait the segment. And the third type is a dynamic routing. Dynamic routing is between router or maybe EG, they will do the communication. I have 3 segments. You maybe have 5 segments. We can exchange with each other. Finally, we can get everything. So this is a dynamic routing. And if you have lots of paths to wait the same segment, pay attention. If you want to wait the same segment, but you have lots of paths, you have to select the best one into your IP routing table. First, you have to compare the administrator distance. Smaller value is better. Then, if the administrator distance is same, you will compare the metric value. Of course, smaller is better. Then, if the metric also is same, all of them will be added into the routing table, finally to provide the load balance. So this is the control plan, how to make your IP routing table. Then about the forwarding plan, all the router will forward the message according to your IP routing table. And I will take the destination IP address to match our IP routing table. Finally, to select the best one, and then according to the best information to the destination. So about the forwarding plan, what means best path? We will compare the mask, longest mask first. If I have the segment of 1.1.0.0 mask 16, and another one is 1.1.0 mask is 24, we will use the 24. So this is a basic principle. And the next part is how to let the router get the routing information. Because you only have the routing table, then you can force a message out. We say we can have direct routes. Direct routes is very easy. Give the IP address, it's enough. Of course, your physical layer and the data link layer data must become up. The typical application is inter-VLAN routing. Like this topology, IT1 and the sales one, they want to communicate with each other. We have to give the inter-VLAN routing. And another one is static routing. If we use the direct routing, but it's not enough, you can use static routing. And this is a key command. IP route and the destination, the mask. And of course, in the bigger network, you can use some dynamic routing protocol to help you to force a message out. And about the dynamic routing protocol, one is OSPF, another one like the RIP, like the ISIs, like BGP. All of them belong to the dynamic routing protocol. And about the RCNA course, we only explain the OSPF. And the feature is OSPF is encapsulated into the IP layer. So we will use a protocol number 89 to indicate OSPF protocol. And when we send out the message, this uses a multicast. And how to let the router get the routing information? It's very easy. What I have, I will send to you. I also receive what you have, something like this. And the whole step is I have to find the neighbor first. The packet we use is hello. And then we will compare with the DBD. how many segments I already have, how many segments you already have. Then we will compare with each other. What I lost, but you have to send to me. So I will send out the request message. Please give me the segment 1.1.1. Okay, I will send you the detail. And I will give you the acknowledgement. What you give to me, I already received it. So these are 5 types of OSPF packets. And then about OSPF, we will have 3 tables. One is neighbor table. I have how many neighbor I have. Then what I receive the detailed information, I will install into the LSDB. And according to the SPF algorithm, I will calculate the best one, add into the OSPF routing table. And in this process, we will have special meaning of the DR, BDR, and DR other. And we have 2 relationships. DR and BDR will establish the adjacency relationship. But between DR other, you can think this is a normal router. We will only establish the neighbor relationship. And we can divide the OSPF into multiple areas. So this is the basic of OSPF routing information. And of course, according to this practice, let's see the configuration here. I also will have some questions to ask to you. First is here. If IT1 want to do the configuration with finance one, what routing we should to add, and which devices we have to do to add the routing information. Can you give me the answer? If IT1 and the finance one, they want to do the communication with each other, direct routing is enough or not? If you think it's yes, please write on yes to let me know it. It's not enough. Direct routing is not enough. Okay. And another question is, when we do the configuration of IT1, we will give the IP address, right? And we will also add the mask is 26. We also will give the gateway. And in this topology, who is IT1 gateway? Can you give me answer? Who is the gateway of IT1? ASW1. Okay, someone say round 1. Round 1. Round 1 usually will becomes edge router to connect with the outnet. ASW1 is a switch. Yes, I think the answer also can understand. CSW1, right? Should be CSW1. Actually depends on your network. Someone maybe say route 1 is the edge of our device, and between edge and the terminal, all the switch will provide the layer 2 function. So the gateway can be in the route 1. And here you will find on this topology, I already gave the IP address between route 1 and CSW1. But about the ASW1, I don't give the IP address. So CSW1 is the gateway of all the terminals of IT department and finance department. Someone maybe say ASW1 also can be a router. Yeah, it's very similar like the Cisco. If your gateway is ASW1, that's why someone maybe say, if we only add the direct routing, it's not enough because Maybe between ASW1 and ASW2, they also need the static or maybe dynamic routing. But now if your gateway is CSW1, direct routing is enough between them, right? Because I will find the gateway, CSW1. Finance one's gateway also is CSW1. They can direct to use a direct routing here. But if you want to do the communication with IT1 and CL1, direct routing is not enough because you will find I will send to my gateway first. This is the first hope. And then maybe I will select directly send to CS2 or maybe route 1. For example, I send to CS2. CS2 have to send to sales 1. So in this step, we have at least 3 hops. We need the static routing or maybe dynamic routing to communicate with each other. So before we do the configuration, you must know which segment we have to add, which technology we have to use. Then you can do the configuration step by step. Of course, if your gateway is route 1, it's very easy. Only to give the direct routing on route 1 is enough. No need any segment between the CS1, CS2, and the other. Depends on your network size, bigger or maybe smaller. So now in this topology, our gateway is CSW1. So let me see the detailed process, how to do the configuration to meet the requirement between IT1 and sales 1, and also the other segment. Let's say the process. Okay, about the CS1, we only have VLAN 1, right? By default. Now you have to create VLAN 10 and VLAN 20 because this is a gateway of the IT department and finance department. To change the mode to become trunk, because we don't have terminal directly to connect with CSW1. Also, the configuration of interface 4, 10 and 20. Then you can create the VSI, interface VLAN 10 and interface VLAN 20 to give the IP address. VLAN 10 and VLAN 20. Okay, pay attention about the VLAN 10 and VLAN 20. This one. When you give the IP address of the VSI interface and also the VLAN 20, this IP address must be same gateway with the terminal. If the IP address is different, finally, the terminal also cannot be forwarded message out successful. Then you will find IT1 to ping the finance 1. You can ping successful, right? First time, if we don't have the routing information, the ping is not successful because we're in the different segment. But now if we ping, we can ping successfully. The direct routing is enough. This pin is the sales 1 to pin the IP address of the sales 2 because they in the same segment and we already added the VLAN, so they can pin successfully. But if your sales 1 want to ping the IP address of AD1, they cannot ping successfully because CS2 also need to add the direct routing. Why I stop here? Because I also do the calculation of the gateway. If you don't use the typical mask like 24 or maybe 16, it's very difficult to do the calculation. And after we add the direct routing on the CSW2, you will find the communication is successful, right? So this is a function of direct routing. And also same of the CSW3. This is a gateway of our server. You have to add the information to create the VLAN 200 and give a mask and also give an IP address. Yes, lots of configuration are same. So if you master one, maybe you can faster to skip. When you do the practice, it will be very fast. If you want to ping with server 1, you will find the destination network address is not reachable. That's because between the server and the sales, we also have lots of segments. So in this scenario, we have to add the static, maybe dynamic routing, and to let all the layer 3 router, layer 3 switch and router to get the routing information first. And here we will choose OSPF. Okay, here we will find about the CSW1, the router. First, you have to enable the OSPF. The command is router OSPF 100. 100 is a process ID, not about the area ID. And you have to enable all the interface, includes the two interface of the terminal gateway, and also two interface, one to connect with Route 1 and another one to connect with CSW2. Okay, so you have to enable everything. And why and what's the key point when you do this command? You also can go back to say the e-learning video of OSPF part. And here, if you use the command show IP routing table on the CSW1, now you only can find the direct routing, right? And this is a direct routing of the terminal gateway, and also direct routing, one connect with Route 1 and another one connect with CSW2, because now you don't have OSPF neighbor, so you cannot get any information from your neighbor. Your neighbor Route 1 and the Route and the CSW2 still not enable OSPF process. So we can continue. On the CSW2, you also can add the configuration here. It is very similar to enable first and then to network the interface to gateway of the terminal and two interface, one connect with CSW1, another connect with Route 1. Okay, now the configuration also is ready. You can find one neighbor here, right? On the CSW2, we can use the command show IP OSPF neighbor, and you already have one neighbor, and this neighbor is CSW1. If now on the CSW1, you use the command show IP routing again, you will find lots of special segment of the characteristic O here, right? O means you get this routing information from OSPF. And here are the detail segment. We will find the two segments of sales department and also of the administrator department, and another segment of the link between R1 and the CSW2. Now, if IT1 want to ping the destination of sales 1 or maybe administrator 1, it can successful. You will find ping success. And here, and about the IT1, you will find the other one is the TTL value will become 62 because we have two hop. One, the first hop to gateway, the second hop to the CSW2, and finally to the destination. According to the OSPF, we can ping with different departments successful. Sales 1 also can ping IT1 successful. But you will find if you want to ping the server, still cannot work because about the Route 1 don't running the OSPF protocol. So on the route 1, you also have to enable the OSPF function. Okay, and pay attention about the route 1. First, you also enable OSPF, right? Then about route 1, we have 4 interfaces. One connect with CSW2, one connect with CSW1, and another one to connect with CSW3. But we have the 4th connect with our internet. Pay attention. On our OSPF, we only enable the private interface, connect with our CSW, but not connect with our internet. Because if you enable with the internet, you will get everything from internet. Your network capacity maybe is not enough. So pay attention about this one. On route 1, now you use the command show IP routing table, you will find a lot of OSPF. Even one segment of this segment, destination of 192.168.1.240. This is a segment between CSW1 and CSW2. This is a load balance. Because the administrator distance and the metric value are same. So this is the result. And also on the CSW3, you have to enable OSPF. One is the gateway of the server, and another one is a link between route 1 and CSW3. And about the CSW3 also can get routing information from route 1. After we add all the routing, you will find the CSW1 to ping the server also can successful. Okay, what is the same process using the RIP and ACL? RIPper is a function similar like OSPF, but ACL is different. What's the default STP mode when enable STP for region? Yes, it also can running, but the higher version will working like the lower version. That's mean OSPF maybe lots of faster mechanism cannot be used because I have to do the configuration I have to do the communication with STP. Okay, so this is a basic one. If we add the direct routing and the OSPF, now we can find all the terminal in our network. They can communicate with each other. So our fourth requirement, we already done. We already done now. About the fourth requirement. Same department want to do communicate with each other, and we want to limit the broadcast domain. And the different department now we also can wait with each other. And also we can use STP to avoid the single failure, right? And we can use VLAN to limit the broadcast domain. So about the routing information, do you have any question about the routing part? No more question? If no more, I want to ask one OSPF question for you. OSPF can help the router get the routing information dynamically, right? This is a basic function of the OSPF. So you can add the route of the whole internet through the OSPF. Because if you don't have the routing information, you cannot wait the segment. So can we use the OSPF to get everything? Also, maybe some route from the internet? Please choose the answer, true or false. Oh, someone said true, someone said false. So can you give me some reason why you think it's true, why you think it's false? Only the neighbor. Yeah, of course, we will get the routing from our neighbor, but maybe my neighbor is A. My neighbor A also can get the routing information from his neighbor B. Then he will send all the routing information to me, includes the routing from B. Only neighbor, but if neighbor can get full, yes, yes. Oh, wow, it's a very good definition. Yes.
Anh nghĩ người con nhỏ mà anh nghĩ chụp người đi để chạy.
Okay. Good. Okay, I will stop to get the answer now. Register route. Whoa, I think you know everything. Okay. Like the video I explained for you on the practice, right? I say when we do enable the configuration on route one, we have 4 interfaces, but we only enable OSPF of 3 interfaces, connect with 3 interface type, connect with 3 core switch, 1, 2, and 3, but not this interface to connect with internet. So pay attention. According to the OSPF technology, if you have lots of neighbor, you can get everything from neighbor. So your LSDB, your neighbor will be very big. And pay attention, how to establish the neighbor, how to calculate the routing information from LSDB. You need the resources. And these resources will have a big influence for your device. So maybe your device capability is not enough to install lots of routing information. So maybe only the career network devices, we will use a very good performance of the device. We can get the routing information as much as possible. But about the private network, we usually only get the detailed routing information of the internet, of the internal device, like the internal device segment of the server, 3 departments, right? But how to visit the outside? Usually we will use a default route, 0.0.0, because if you want to visit outside, we only have 1 out interface, or maybe some scenario we have 2 interfaces, but we will do the route summary to reduce the routing information on your table. And then, how about the CSW1 for the message to outside the internet? We also need the routing. We can use the redistribute the route. Route 1 also will use the OSPF to tell CSW1. If you want to visit outside, you can use the default route. Send the message to me, I am route 1, and I will use the default route to visit outside. So that's why in the next scenario, maybe they want to visit outside. And then about the outside, we have very big network. But in this topology, I only use 3 devices to simulate the ISP. But in real network, the ISP will very big. So in this scenario, how to visit outside? First, you have to solve the problem of the routing. Second one is the private network. We will use a private IP address. How to visit outside? We will use the technology of the net to translate the IP address to become public and then to visit outside. So this is the 5th scenario. We will use a new technology of the net, ACL, and also special routing information in the public network. So first, let's say, if you want to visit outside, for example, here, only the IT department and the sales department can visit outside, but the other one cannot. So how to select the message from IT and sales? We will use ACL, access control list, to select. And the function is we can select some special message or maybe some special routing according to the access control list. And the application is when ACL selects the message, we can use the innet to translate the private IP address to become public IP address. We also can use in the QoS. For example, we want different terminal have different priority. We also can use some packet filtering. For example, this message, if I receive, I will directly discard, something like this. And how to select? Typical classification, we will use standard ACL and extended ACL. The value number is different. And about this one, you have to remember it. And different vendor, maybe the standard ACL and the extended ACL number will be different. And the action, we have 2 actions, deny and permit. This is the ACL. And about the net function is, because we use the IPv4 address, we only have 32 bits long. And now this IP address is not enough. One is you can direct it to use IPv6 because the IPv6 address, we have 128 bits long. So the IP address is enough. Another one is you can use the technology net to make the IP address to become private and public. So about the private IP address, in different scenarios, they can use same private IP address. But if they want to visit the same internet is a public network, they have to translate IP address. Otherwise, there is an IP address conflict. So this is a segment of private network. Maybe in your home, you connect with your Wi-Fi, you will find the IP address belong to this segment, right? And also maybe belong to this segment. In the classification of the net, we have static, dynamic, overload, and the server port mapping. So they are different type. Do you have any question? If no, I will mute you first. If you have any question, you can write down on the chat window. Okay, so this is the net. And now let's say if we only want the IT and the sales department can wait outside, how to do the configuration to meet the requirement. Okay, let's see the process. The next step, right? About the ISP1, this is a router here. Because about the initial configuration, I only provide the IP address. So ISP1 also doesn't have the segment of ISP client. And also the other segment, we only have direct routes. So how to get the segment of the client, you also can use the OSPF. Okay, we can see this configuration here first, and later I will answer your question. ISP1 and also ISP2, because about ISP2, we only have one segment, only have two direct segments. We need the routing information. We also need time to wait our neighbor establish successful and then get the routing information. So maybe after you're waiting the configuration, after you finish the configuration, you still have to waiting. In current scenario, if IT want to ping the destination ISP client, you will find we cannot ping successfully because we don't have the routing information. CSW1 don't know where are the 200 segment. Route 1 also don't know where are the 200 segment. You will find we don't have any routing information on CSW1, right? Because about the IT1, I will send the destination to my gateway. The destination is 200.1.1.1. When CSW1 receives this message, I will take the destination to match the routing table, but I cannot find. So finally, I will directly discard it. The same of R1. R1 also don't know where are the 200 segments. So we have to know this information first. You can give a default route on Route 1. Okay. If you add a default route on Route 1, right? This is a static route. In the about CS1, we also don't know what is default route. Where is default route? I don't know. So how to let CSW1 know the route default route? We have to make the default route to become OSPF route and directly from Route 1 send to CSW1. Or maybe you also can add a static route on the CSW1 directly to wait R1. Redistribute the static subnets. And the default information successful. So now if you check on the CSW1, you also can find the default route here. Now I get the default route from my neighbor R1. Can you ping successfully now? On IT1, you still cannot ping, right? Because why we still cannot ping? Now I send the message to my gateway. My gateway also has the default route to Route 1. Route 1 also have default route to ISP1. ISP1 also, according to the OSPF, I know the next hop is ISP2. I will directly send to the client. So in this path, it can success. But when we reply, the destination will become 192.160.1.1. I will send to my gateway. My ISP2 will take the destination to match my routing table. I can't find the segment of I192. So I will directly discard. So I will send out the message successful, but I cannot reply. So the result is timeout. So we also need to let the ISP2 know where are IT1 located. But how to add the routing information? We cannot directly to do like the default route to directly redistribute the private segment, because lots of company will have private segment. So in this scenario, we need the net. This is a process. ISP1 also don't know where is 192. So we have to use the net technology. And about this net technology, it's a little difficult because I give you special public IP address. By default, usually we will use a public IP address same with this segment. It's very easy. But now I give you a segment is 185.1.1. That means your public IP address is different with your outer interface. So in this scenario, you also need to add some special static routing. On ISP1, you have to here is a Route 1 configuration. Route 1, first you have to create ACL to select which department can wait outside. One is the IT department, another one is sales department. we can support we can support mapping. Region we can support the static route, static net, and also the dynamic net, and also the overload. Now is a configuration to create the public pool. Usually the public will be same with the interface. Same segment, not be same. Okay, here are the key points of the net. First, you have to create the public pool, right? Of course, if you use some EG, you can direct it on your website to add the start IP address and the end IP address. It's enough. You don't need to remember the command because it's a little difficult. Another one, you have to set the interface to become the inside or outside. Inside means I receive this message, I will to match the ACL. If belong to the ACL list, I will use a public to do the translation. And where I will send out the message, I will directly send out to the outside interface. So this is route 1. And which access list will use which public address, you also have to add the relationship on the route 1. Okay, this key command, we will use access list number is 10. We already select IT department and the sales department, and we will get the public pool of the region pool. Overload means I will translate the IP address and the port number at the same time. And if we don't add this key parameters, that means I only translate IP address, but this is different with static. Static means public A only can be used for private A, but dynamic is public A can use private A can use public A. If private A not use private B also can use public A. So this is static and dynamic. Okay, so this is a configuration of route 1. And about the ISP, we don't have the segment of your public IP address, right? So we also have to add the routing information. Let route ISP1 know and also let ISP2 know. Now ISP1 knows the public address from route 1. We also have to let ISP2 know it. Then on your ISP2, you will have those public information, right? At the same time, you can pay. Now we can pay successful. Sales 1 also campaign successful. Yes. But administrator 1 cannot, because we are not in the access list. Ping-T, that means we will ping all the time until you use a command count and C, we will stop it. Then you can choose see the net session. We will find which IP address already be used for which private address. Okay, now you can stop here. So this is the basic one of the net, right? And the last one is configure last requirement. We want to telnet the private address. Why this telnet is special? Because maybe you are in the public network. Now you want to remote the CSW1, but CSW1 located in the private network. So how to remote successful? One is in public and another one is in private. So in this scenario, we also need the net. CSW1 needs a public IP address. So key configuration on first, the key configuration is on the CSW1. You have to enable the telnet service. You have to allow the other one to telnet your device to do some configuration. So the command here, how to enable on the CSW1 is the key configuration here is line VT1 0 and 4 to set the password. And choose the protocol to become telnet. This is a basic to enable the telnet service. And the telnet interface is a logical interface. So you have to enter the line VTY and to give the password. And this password is too weak. In the real network, suggest to give higher security password. And you have to choose the transport to become telnet. And another one is SSH. Also the other way to remote access. So this is a basic on the CSW1. And another one is you have to provide the public IP address for the public client. Suggest to create the private address. The loopback interface. This is the logical interface will never shut down if the switch is working. Then on route 1, the key configuration here is IP net inside source static. We will use one public IP address only for CSW1. Now you can test on the router ISP2 and to use a command telnet. When you use the command, you have to wait the public address. Password is 123456790. Then you will find we already telnet successful because now we wait the CSW1. And you also can do some configuration. Okay, that's all about the whole process, how to meet 6 requirements, right? And after you do the configuration successfully, please don't forget to save the configuration. So about the 6 requirements, do you have any question? I already see the answer. I have one answer from the private to private, right? I remember someone asked me the question. If you want to wait from private A to private B, but between them we have public network, you can use a VPN technology, not about the net. Of course, you can use one we call is bidirectional net to wait with each other. So that's all about the basic net. Do you have any question here? If not, maybe on our RCNA course, we also have the other technology like the DHCP, right? This one also is very useful in the real network, but maybe in this integrated lab, I don't add this feature on the topology. And about the DHCP can be used to assign IP address dynamically. And we will use the UDP to encapsulate the message. And here is the key configuration. If you want to use the DHCP, you have to enable the service and create the port and what's the segment, what's the gateway, what's the DNS server, and how long you can use this IP address. And this is the DHCP relay. If your client and your server are not in the same segment, you have to add this command here. And another one technology we also can use is VRRP. Like this one, if you have this terminal is very important. And if you only have one gateway and this device is broken, they cannot work. They cannot work again. So in this scenario, you can use a VRRP. And here also is a key process, how to work of the VRRP. You can select, after you add the configuration of VRRP, we will select one is master and another one is backup. Only master can help us for the message out. If master is broken, we will use a backup to become a new master, then to forward the message out. So this is the VRRP. So that's all about the RCNA course. And at the beginning, I do the server. Someone don't see the video on the e-learning. Maybe you don't know this course, but it doesn't matter. I already show you how to wait the e-learning course. And because on the e-learning course, we have nearly 19 hours to watch 50 videos, then you will master everything. And of course, today's integrated lab was a key point like OSPF, how to work, how to find a neighbor, what's the meaning of each command. Everything I already explained on the e-learning video. And if you see everything and pass the exam, and you have the simulator, you can use the same topology to do the practice. Maybe first time you can try by yourself. And then you can follow my video to check the step. And this is an integrated lab. If you can finish the lab by yourself successfully, I think you master everything. And of course, if you have some cooperation with your colleague, you can let your colleague set some troubleshooting faults to let you to do the troubleshooting. It will be very interesting. So this is the RCNA course, the whole step. And how to wait the RCNA course, I already explained for you, right? You only need to register the account of the region of official website is enough. You can directly click here, support e-learning, find our roadmap. Then you can learning everything. And about this course, the public training, the summary course, I also will add in the roadmap in the future. So maybe this time you don't know what means command. You never use command before, but after you learning everything on the e-learning and then come back to watch the video, you also will get lots of information. And another one for the whole process, the integrated lab, I show you some files, right? And these files I also will add on the e-learning. Let me introduce about this one. First is the public training of today. I show with you step by step, what's the scenario, what's the key point. And another one is the initial configuration. If you have simulator, or maybe it's better if you have lots of devices, you can make the connection like the summary topology. Then you can add some initial configuration, but on the initial configuration, only the IP address of all the interface, not the other information, because I think configure the IP address is very easy for you, but we have lots of interface. Then you can do by yourself, try to meet the 6 requirements. Then if you are not very clear, or maybe you have some question, you can follow the video, this video. Because in this video, I will show you step by step, what is the first switch you have to configure and what's the first command you have to add in the switch, something like this. And finally, if you finish everything, I also save the command and on the full configuration. So after you finish, you can copy your configuration and compare with my configuration. You can check maybe which line I have, but you don't have, something like this. So all the files here is help to you to finish today's integrated lab, not about the learning video, not about the exam. So this is the material. And this part, I also will add on our roadmap. On our roadmap, I will have a new topic for the integrated lab, okay?